Hi there! Let's go for another day of Advent of Code 2022. Today we are working on day 9. I think it's gonna be fun. I've read the problem statement already. Just before we start, I wanted to share about this project that I'm working on full-time. This is like a startup that I'm building from scratch. And this is actually how I am creating the thumbnails for the YouTube video. So basically you have an editor here. You can change the text, change the position of the text, like add multiple layers, images and everything. And then you have an easy way to change the frame. But let's say you are doing Ruby for day 25. Just a click away, you can generate an image. And you can then plug this into Zapier or anything like that to automate your image creation. And so every day I'm just coming here, and this is gonna be the thumbnail for this video. So this is like kind of a little ad for a project that I'm doing. I hope you don't mind. Let's get started right away now. So this is day 9, and as usual, we are just taking the input and starting with input parsing. I'm pasting that inside our little local file. I am reusing the template that I'm using every day. And what do we do today? For each line, so the map here, for each line, we want to do line.split with a space. We want the letter, so const letter and number, and here I'm gonna return the letter is a direction, and total moves is gonna be parse int of number, because when parsing it's always good to change the numbers in the string that are representing a number into an actual number, because otherwise you get some bad surprises later down the road. So as usual, we do a little console log of lines just to see what's happening. In this video, in this series now, I'm trying to really go slow and do the right thing. And so in the end, it's just working right away. So we have exactly what we want. So now we're going to have to say const x equals 0, const y equals 0. This is going to be the starting. Oh, no, it's not constant, it's let. The idea is that we want to represent something that moves around. So we have actually two things that move around, the T and the H. So how should we do that? I think we can make a class today. I am usually not doing classes, but here it looks quite a good idea to do. So I'm gonna try to do the class like that right away, and we see what happens. So here we're gonna say const what is this point? This is gonna be T. So here we can use a const. I'm gonna do new point of 0, 0, and const, what is the other one? H. Oh, so this is the tail. Actually, let's do tail and head. So we know it's head that moves, because usually one letter variable, not found of that outside of x and y. So head and tail. Let me just make sure. Tail. Okay, so we have our 2 points. That looks correct. So we can build on top of that. So next thing we want to do is we want to provide a move. So we're gonna say move direction, and here I want to encode the 4 directions. So we have right. Right is x, this is +1, and y, this is +0. We have up. Let's do left first. We do right, left, and up, down. So for left, we have x is equal to -1 and y is equal to 0. Up, x is equal to 0, y is equal to -1. Yeah, so we're gonna basically have x that goes this way and y that goes this way. So up is -1 and down is yeah, so the thing is, we don't care really. There's no, it's not important if we put y this way or this way. We just have to define this once and stick to this definition for in all the duration of the problem. So here this is 1. When we go down, we do y +1. So here we do that, and basically this is a cool trick. Actually, let's, you know what, let's move that outside of the function. Const move definition. Oops. We do equal that. Moves definition. And basically we can do here, the delta is move definition of direction. So now we have our x and y, and we can do this plus x plus equal delta dot x, this plus y plus equal delta dot y. Now, one thing that we have done in the past days, we want the list of the number of visited nodes, if I'm correct. Visited at least one. So we know, we already have a trick for that. We have a new set like that, and we say a function visited xy, and we say let's say mark visited xy and the visited set. So we can say visited dot add yeah, like that, x dash y. So basically here we initialize everything and we mark mark visited 0 0. Okay, so with that we have our 2 points starting at the position 0 0. We mark this position as visited. I believe we need to mark the start as visited. And yeah, now we need to go through each of these inputs. Let's do that. For now, we're just gonna be moving the head. Let's do that. For of line of lines, we have in each line we have a direction and our total moves. So because we have total moves, we need to do a for loop line the total moves, and here we need to do head dot move line dot direction. And when we have moved, we need to mark visited head dot x head dot y. Yep, I think that's it. So now we can display in the end visited. No, because here what we care about is what the tail visited. So let's not, so that's not correct. Here we can remove that. We can display the head basically. So here with that, we're gonna display where the head is moving to. So let's see, we have this example. The head is moving to the right, yep, until 4, then up 4, so yeah, 1, 2, 3, 4, then actually let's check that, left 3, so it goes back to this point, and then we have down 1, it's correct. Actually I can open that here, down 1, that's correct, then right 4, so this, yeah, this increases to this point. It's always good to just like check the output manually. Down 1, that's correct, then left 5, it goes to 0, and then right 2, okay. So we have something that is working. Now we need to move the tail correctly. So in order to do that, we need to we're gonna put another thing here that's gonna say follow, and it's follow a point. So basically here we're gonna say tail.follow head, and we can mark visited the tail.x and tail.y. That's gonna be the idea. And here is gonna be the magic where we actually implement the logic of this puzzle. So we're gonna need to check the distance, const distance. And the distance between the two things, it's the Manhattan distance. So I'll let you look it up, but basically it's the maximum between between the difference between this.x minus point.x and math.apps this.y minus point.y. This is going to be the distance, and we need to check if distance is above 1. Then here we need to move this point. So we're gonna display move, and the idea is that, oh yeah, we disabled, I wanted to console log head, so I wanted to check if when we are moving, okay, so for example here the first time we move the head, we don't move the tail, but the second time we move the head, the tail has to follow. So here we already have something that's coded that works, and maybe that's not correct. Oh yeah, we don't move the, okay, let's say, yeah, now we need to actually do the move, because here we can look at the first thing, but we haven't updated the position of the tail. So here we need to actually update the position of the tail. So we need to make it follow the other point. Let me take something to draw. Okay, so we have the head here. Let's just copy paste it. We have the tail that's here. So basically we have to do 1 and 1. This is one example that's possible, where basically the head was here, so it was just diagonally next to it, and now it's moving again, so we have to know how to move the tail next to the head, and the tail basically has to move 1 to the right, 1 to the bottom. So how to do that? I think what we're gonna do is we're gonna do something like So we want the tail to, so if we do tail.x minus head.x, we have here, let's say this is actually position 0, 0, so 1, so this is 1, so 0 minus 1, so this is going to be minus 1. So we need to do the opposite. To get the direction where to go, this is going to be like that for x, direction on x, and the direction on y is going to be the same, is going to be head.y minus tail.y. So this is going to be equal to 1, and this is going to be equal to 2. So I think we have something going on here. So I just need to, there are too many things I'm thinking at the same time. Let's start slowly, you know. So here, const direction x is equal to, we said, so head is, so this point here, this is the head. So point.x, and the tail is the current point, this.x. And we do the same for y, point.y, and this.y. So we have the direction, but this could be a number between -2 and 2. And we know so if this is 0, we don't want to do anything. And if this is any 1 or basically, if direction x is 0, then we do nothing. If direction x is 1 or 2, we do this plus x plus plus. If direction x is -1 or -2, we do this dot x minus minus. Yes. Yes, that should be correct. So is there a clean way to write this code, or should I make like a 3-if? So typically I would do this dot x plus equal direction x. However, when this is 2, we can do math.apps. If this is equal to 2, then we do this divided by 2, otherwise just do direction x. So I think that's correct. Because if this is 0, then we add 0. If this is 1, we just add 1. If this is -1, we add -1. And if this is 2 or -2, this is true. So we add 2 divided by 2, which is 1, or -2 divided by 2, which is -1. So I think we have our code that is compact, nice, and cozy. So we can just do the same for y. And I think we have something that's correct. Let's see. So for example, here we move to the right 4 times. Then we move up. And the first time we move up, we are not moving the tail. They are now diagonally. And then we move again. Then when we turn again, we don't. Okay, I think we have something that's right. So today I don't want to visualize. So yesterday I've like made something a bit complex to display the state and visualize the progress. But today I just want to. I just let's try if it works. And if it doesn't work, we go through the full thing of displaying and debugging. Let's make sure we don't have any console logs. Yeah, I think we're good now. Yeah, we have 0 console logs. So now we just need to display the size of the visited set. We mark the point 0 as visited, and then we mark the tail as visited every time. And sometimes this function is not moving the tail, so we mark the same node several times as visited, but that's not a problem because this is set, so it's deduplicated. So we should be good. We have 13, which is the number that we are expecting. Now we can go and take the full input. Let's see. Okay, have a big number. It was really fast to run, so I think we are good. Let's go to part 2. Let's see what's happening now. I'm going to read the problem statement. So the problem statement is scary, but at the same time, I think we are in a good position with the code that we wrote so far. So let's check that. So basically, previously, let's go back to the simple example. Previously, we had just 2 points. Now we're gonna have 9 points. Scary. So we're gonna copy paste the problem statement here, and basically we have an array. But we're gonna make an array right away here. Const nodes. This is a new array of how many? What is the length of the array? 10. No, 10 nuts. Here, in order to create something, I like to do that. Basically, you need to use fill 0 to make an array of 10 with 0 character, and then you can map it, which is, and then we're just gonna say whatever. We do new point 0 0. Okay, so these are gonna be our nuts. Yeah, let's call it nodes because nut, I don't know how to pronounce that correctly. So we call that nodes. So here basically we just need another for loop here for and this is gonna be nut. Let's call that nut from 0 to nodes. You know what, let's rename that. Let's rename nuts because otherwise that's just a bit confusing. So the nut index here, so basically the current point is nuts of nut. So the thing is, the first, so nuts of 0, we need to move it using this function. So nuts of 0, we need to move in the direction the problem statement is saying, and then, so this is like the move the head according to the instructions, and then here we move the rest of the rope. So here we can start at 1. And we're gonna say the point must follow nuts of nut minus 1. Basically, we say the element at the index E follow the element at the index I minus 1. And basically, we just need to mark visited. So const the tail is equal nuts of nuts dot length -1. Is there a cleaner way to write that in JavaScript to get the last element of the array? I'm not sure. To be honest, I'm always using that. I need to check at some point if there is like a better way, because that's annoying to have to repeat the variable name here. So tail.x, tail.y visited. I think this is all there is to this problem. We thankfully have like a nice function which is follow to help us. Have like a nice class here. So yeah, I'm really thankful I went with an object here, because that makes it super easy to do. So here the node just moved once, the tail just moved once. So let's see. Okay, there is something. In this example, the tail never moves and it only visits one position. So we are good. So yeah, they say you should visually compare the simulation rope to the above. To be honest, I feel quite confident, so I think we're just gonna go right away, because I'm not really feeling like displaying the full thing. Okay, oh, here we have like something that's more complex. So is there like the example for that? Larger example, perfect. Let's take the larger example. That will gives us confidence that we are on the right track. This is 36 positions that have been visited. Let's see. 36. I think it is time to use the full input. Yeah, like as you see, going slow is really nice, because then everything comes together. That's really exciting. That was fun. So yep, hopefully you liked the video today. You liked how I solved it. It was clear enough. Don't hesitate to write some comments. I'm replying to everything. Yeah, thank you very much for following this series again. If you haven't subscribed, drop a subscribe. If you haven't dropped a like, do it. It helps the video be more visible to other folks who might need the video. And thank you again. See you in the next one. Bye bye.